let's talk about the change of base theorem. A while back we mentioned, if we have nice numbers for our logarithms, we can do all those all day long. Log base 5 of 125, we can do that. Just 5, that means 5 to what power is 125, right? That would be 3. 5 to the third gives me 125, so that logarithm is 3. Well, that's all good if we're talking about a nice number in there. What if I had log base 5 of 43? Well, obviously, that was not so nice of a number because that's not a nice power of 5, is it? 5 to what power gives you 43? And most people recognize that as not being a nice power of 5. However, there is a power of 5 that gives you 43. It's just a decimal power. 5 to the second is 25. 5 to the third is 125. So it's somewhere between 2 and 3, right? The power is. How do we get it more precisely, though? Well, that's where this comes in, the change of base theorem. And change of base theorem works like this. If you have the log base A of B log base A of B, then you can change your base really to any base you want. This has base A. I'm going to change to base Ln. Here's the way that works. Log base A of B equals in Ln base, it's Ln of B divided by Ln of A. And that actually comes out of, well, both the exponential and logarithmic equations. Look at this. Log base A of B equals y, some number. Well, if I treat that as a log equation, exponentiate both sides to log base, it's log base A, so exponentiate both sides to A, the A in the log. Okay. Well, the thing of that is I need to solve for y. So if I solve that for y, that's an exponential equation, so Ln both sides. Because then the y pops out, and I have Ln of B. So Ln of B equals y Ln of A. Solve for y, divide by Ln of A. There you go. Y is Ln of B divided by Ln of A. So log base A of B, equals y. Well, y equals Ln of B. That's where it comes from, okay? So it works. All right, so what does that mean for us up here? Well, that means up here, I don't want to say, well, 5 to what power gives me 43. I want to say, to evaluate that, you take the Ln, the B is the number here. So the top number up here would be Ln of 43, wouldn't it? This is the B. Divided by the Ln of the A is the base, so I divide by the Ln of base 5. So I do that, that'll give me an approximating value for this logarithm. .33696. 65. Okay. So like we said, somewhere between 2 and your 3. Yes, ma'am. Yes. Well, if it starts with a natural log, then you don't have to change the base, because that's what we change it to Ln because we can do that on our calculators. Most calculators, some calculators actually do other bases other than Ln, but if it starts at Ln, you have no problem. You can just punch it in. Right. Okay, so yeah, you can do this any base. Ln of log of 7 of 10,250. I'll just do the ln of 10,250 divided by the ln of 7, right? That'll get it for us. That gives me I get 4.746. Let's just do that. 3, 4, how many ever places it wants, okay? All right, so yeah, that gives us a way, and it works for these, but I still want you to know how to do it this way for these, for the nice ones you can do. But it works for this, okay? The change of base would work for that, but it's not totally necessary. But for ones like this, yes, utilize that. Okay?